Moving on, this section of indefinite integrals revolves around the power rule and the constants. As expressed here to your top right, the antiderivative of x to the n and the antiderivative of a with their respective formulas. Okay, so the first example, you are trying to find the integral, you're trying to integrate 16 dx. 16 is a constant, so you integrate the 1 and you end up with 16x plus c. Now for example 2, you have the antiderivative of 5x squared. You take out your constants and then you apply the power rule, which gives you 5x cubed over 3 plus c. Now you're just pretty much doing the same thing for 3. Might I warn you though that if in doubt, then you have to simplify the fraction, which is just algebra after you do all the calculus provided. That's the power rule. Then you end up with 32x6 over 3 plus c for the integral of 64x to the 5th power. Now for this big one, it's more of like a big constant. You have the integral of 2y, the fractional power of 7 over 2, times hyperbolic tan a, integrating with respect to dy. Be sure to note that right away. Don't let the hyperbolic tan throw you off, because it's just an arbitrary constant, just like number 2 is. So we drag out all that constants, and then we're just integrating y to the 7 over 2 with respect to dy. After we integrate that, we're using the power rule once again. For the denominator, you take the reciprocal of 9 over 2. Once you completed that, you end up with the 2 times 2 over 9 times tan a, hyperbolic tan a, times y to the 9 over 2 plus c. And in return, your final answer is 4 over 9, y 9 over 2, times hyperbolic tan a plus c.